Just find the right place in the program, make the appropriate change, and we'll run the whole thing again. Speech is still very complicated. Music is simpler.
Is that a question?
Yes.
The question is futile.
My interpretation of the data leaves little room for error. The art of leadership is delegation.
That information is not available. This constitutes all available data.
You know what they say. No good deed goes unpunished.
Cardiff now 125855.
How do?
855, radar control.
How are you doing? Welcome to 41. Not the meaning of life, not quite. Getting rid of Backlash. Last problem. So, I've done a few things off screen. Done a few things off screen. Anyway, right, so what I've been doing. I found out why it was not. Hold on. I found out what was going on last time with the switching not quite coming back, and it wasn't sticking. It wasn't the motor power. It wasn't sticking. It was backlash. So it was the shaft moving inside when it hit the stop, and it's reversing. It was bit of play in the shaft, so I've redesigned it, and to prove that it was that. Anyway, let's have a look. So hopefully this is the last problem to solve the contacts working great now, the switching of the actual contact. Anyway, let's just have a look at so we've got the normal one. Now this is a different one, trying to solve a problem. This didn't work. Anyway, both of these have been upgraded with the new switching. I'll show you that in a minute. Now this one, if you have a look, it's got a coupler inside it. I've had to design a new spacer, and this one has got zero backlash. I can't say zero, but it's got nothing that can be detected. But it extends the height. I didn't want to extend the height, and it needs to include this coupler, which is more expensive. So anyway, this is this solution, but I still want to go back to the compactness of this one. So I need to, I've redesigned the middle with a spacer, a sleeve, that so if it wears out, but that's introduced double the amount of backlash. So that will work, but I don't want it like that because it's too big, and when you put it in the enclosure, it's going to have to be a bigger enclosure, but it would work like that, and it means more parts. So we'll keep that one as a backup plan. So this one, I'll have to go to the model for this one, but in this one it looks the same as the old one, but it's slightly different. Put that down. Let's go over to the model. Okay. So we got, I'll show you what changes are made. So this standoff here, let's show you what we've done here. Hang on. So we've got this piece that sticks down, and this is to go with this longer idea. So this one idea, which is a backup plan. It's just a backup plan. So basically what happens is that, oops, that pushes down. That is part of the base, so if I double click on that, it's all part of the plan. Now it's part of this. Now what you can see at the minute is you can see two lots of these, so I need to remove one lot. No, that's that one. So I go up to stepper, modular, shaft, bottom. Yeah. So what we've got is this one here. That is a single unit now. That's the single unit. So basically it's added this 8mm diameter sleeve over the shaft. So that one fits over the stepper motor, which you can't see, so let's just go into this. So it goes over the shaft, but it goes inside here, which is an 8mm down to a 5mm coupler. So that sleeve was the idea that, yeah, that one goes in there, and this is not showing the screw, but on the real one you've got a screw that you tighten up onto that other shaft, which is, you can't see it now, this one. So that pushes over it, and then you tighten your screw, and then there's no backlash then. So that does work, but we don't like the idea of making it too tall like that. So to go back to the other idea, let me just remove some of this stuff. Right, hang on, which one is it? Stepper motor long. So take the stepper motor long and the spacer. Right, and the coupler off, and the base stepper motor. Hang on. So where is it? We just like to find it. Contact. I can't remember which one it is now. No, it's none of them. Stepper motor spacer. We want the. So that's the spacer. Oh yeah, there's the motor and the spacer. Yeah, so this is what we've got back to as we had before. So we need to move. Hang on, let's go into this. Yeah, that's not the right shaft now. So that's got to be changed. Spindle, SN bottom. Take that one off. And bring back the bottom, which we should have already brought back. There it is. So this is what we've got now. Well, this didn't actually work. So I've got a sleeve. I've made this sleeve, so if it does wear, you can remove the sleeve and put another one in, push it in without taking it all apart. But what that did, it just created two lots of possible backlash, one in and one outer. So, and then you've got the receptacle part in the base like that. So that actually helped a bit, but it was still got some backlash. So no good. So what I want to do today is change the design of this and make it a flat. I reckon I could get rid of the backlash if I made both sides flat. But you still got to get your motor shaft through the middle. So rather than print a load of these out and then they're all wrong. So anyway, we got rid of the backlash with the long motor, but in order to, if I just hide that a second, spindle, hang on, where is it? Sleeve. Yeah, so if I hide the sleeve, so this is what you end up with. This is how it would look at the minute, but this won't do the trick. So I've got to work out how I'm going to get rid of the backlash. So what I need to do is probably turn this into a flat. I can go flat across there and across there. Now, this is the bit I'm trying to work out. I went ahead and did this without live streaming the other day, thinking it might do the trick. I've got one here. I've got one I printed out earlier. Let me just grab some pliers. All my tools are sort of piling up. So I'll just grab the sleeve. That's it. Pull that on. Oops, I always drop it. Every live stream I drop it. Alright, so just take that out of there. You can't see. So I've ended up... Why is the camera so high? So I've got this bit with a flat on it, and that bit as a receptacle. But when I put... So that would go over the shaft. The shaft of the stepper motor would go in that bit. And that's quite a tight fit. But then I'd push that into there. Like that. So, but if I grab it, they're still playing it. If I hold that, hang on, hold it in this hand, 'cause it's got a bad arm. I can actually move it that much. I'm holding it still, and I can move it that much. And if you really go crazy, you can move it all the way around. So obviously that's no good when you hit the stop, and then you change direction. It's taking up the play, so hence it's not switching the actuator to the right position. So what do I do about it? So I'm thinking, can I turn that into something else? Two flats, like an oblong. I'm not sure if that'd do it, so I'd have to try it. So might have to go back on the fallback one. So you might have to end up doing it this way with this thing, this coupler on the shaft, 'cause that tightens up on the 5mm shaft. Then I tighten the top bit up onto the plastic shaft that I made directly off the base of the shaft of the switcher, and it's tightened up onto the 8mm of that. And this one works okay, so I put it on test. Let's just put it on test, shall we? Put it on test. There's no backlash, so it's not the software, it's not the switch getting tight or anything like that. It's just the play between the metal and the 3D printed plastic. So I've got this one on here. So if I just switch it now, let me hold it up so you can see, like that. Right, here we go. So I'm just going one at a time that way. Alright, that's at the end, and if I go back, see, it's working perfectly because it's connected. There's no backlash. Okay, now if I take this off and put on this one, which has got the backlash, the play in it. So let's hold this one up. We'll go through the same motion. So it's already missed it. Look. Alright, so if I go again, it seems to be alright the one way. No, it's not. That little bit of, and if you notice, it goes from under the 2 to under the 3, under the 4. So it's okay once it's taken up the backlash, the play, it's fine. Right? But as soon as you make the first move in the opposite direction, it's a problem. So how do you solve it? Now, can you solve it in software? Possibly, but that's not the right answer. Let's just try again. So if I go like that, I get to the end. If I keep pressing it in, it'll inch, goes single steps it over to the end. Now, once I'm there, the first one I do in the reverse is a complete 45 degree, which doesn't take it to the right position. How can I get that to face you there? Right. So it isn't there. So what I need to do, if you're going to try and do it in software, you'd have to step it back, single step it, but you can't tell you're on a remote. So there's me thinking the stepper motor wasn't moving or getting stuck, but in fact it wasn't. It was just the fact that there's play between the metal shaft and the plastic. So if I put this on a continuous test, how can I face that to you? Yeah, it's constantly. It's always going to be out. You see, as soon as it changes direction, it'll be out. Now there is a little bit of leeway. You've got a few mil either way, so even though it's not quite pointing, it might still be on it. So obviously that one's no good, so let's just take that one out of there. See if I can put this back in live, I don't know. So you got your long one again now, and obviously that just works straight away as it should. The mechanism for switching is exactly the same apart from the end bit. So that one's fine, and I can actually hear the contact switching inside. Anyway, it's masked by the ball. So let's just stop that a minute. So I'm just going to stop that and switch the power off. So we're close, but I need to. Is there a way I can modify this without having the coupler, or without having this spacer coupler? Hang on, let's get rid of the small stepper motor. I don't know, small motor. Where are we going? Stepper motor. Turn that one off. So we've got this on the spacer. So we've got this, and we want yeah, those two, and the coupler. So this way would work, but it's too long. And I'd have come up with this in the first place, I wouldn't have said anything. But it needs to have a coupler to join it. That coupler, but that's more expense. And I would like to see if we could get rid of it. So if we go back to, hang on, spindle sleeve, right, so go back up to the motor and spacer. So it's, hang on, that's the wrong thingy bob. That's the wrong one. Let's turn that off. Right, so we want to give back the which one is it? The base spindle bottom. Oh, it's already there. Oh, it is there. There it is. So that's the one with the little insert. So that's what I've got so far. The sleeve. Yeah, so the only thing I've changed is this bottom bit. So I can change that now again, but how do I do it? So still, at some point, the shaft of the motor, stepper motor, goes into this bit here as well, and it'll go through there via the sleeve. So all I've done, so I don't know whether to try and modify the sleeve, leave it like that, or actually make it a complete flat, both sides. Because what I've done now, because I've got a removable sleeve, I've introduced, you've got Backlash in here, and you've also got Backlash in here. Two lots of Backlash. So I don't really know what to do. I could try a flat. So let's just try a flat. So we've got to maintain the flat here, and I'd like to have a sleeve that fits in there. But the more parts you have to 3D print, yeah, so that I've answered my own question. The more parts if you slot a sleeve into there, then you've got 2 lots of backlash to deal with instead of 1 lot of backlash. So that's the size of the steel shaft of the motor, so you've always got to keep that. But seems mad, doesn't it? Seems mad to just create a square block when it's the middle bit that's the problem. But the minute I've just translated the problem to this bit. So what do? They reckon you're supposed to have a split. You have a split and then you tighten it up onto the shaft. You put a fixing in the side, and as you tighten it, it just gets rid of the play. But the only other way is to have such a tight fit. That, or model there's something not quite right. I don't know what it is there. Obviously, if you free it up, and there's not much holding it back, it'll work anyway. That's why one of my earlier models worked fine, because it was freer. So I'm a bit stuck now. So do I make the sleeve tighter? No, it's not just the sleeve though, is it? But that sleeve actually, the sleeve actually, this bit it's better if I show you in X-ray probably. Apparently when you 3D print something, even though they're both exactly the same size, there's a discrepancy. So you've got to make it smaller. Now if I make it smaller, the shaft goes all the way into there. Let me if I come out, you'll see the motor shaft. Hang on, there's too much to look at, so yeah, let's hide some stuff. What can we hide? SR239s, shells, lids. Alright, and stepper motor spacer. Oh no. No, it's not that one. Base, there it is. Stepper motor base, I haven't seemed to got it. Where's the stepper motor base? It's not there, is it? Stepper motor fixings base. Can't seem to find it. Can't find that base. Why can't I find that? Stepper base. Right, okay, so it is that. Yeah. So basically, that shaft that's part of the stepper motor goes all the way into this point here. It goes through all that, and it is a tight fit. Tell you what we'll do. I'll grab a stepper motor. Have I got a spare stepper motor? I've put them all on things. I've got one on an older model. There's an older model. Right. So there's an older model. Just wondering is that older model. This one's probably looser, so it's not so much clicky, this one. So this one will probably work fine without the backlash. Let me take this apart. Take this apart and use the stepper motor off here. Put it onto the shaft. So I've just got to take this apart. Oh, I've got a little tool to save me. Electric screwdriver. Oh, that hurt. That's how I've got a bad arm. So if I just loosen them and then I'll just wind them out quickly. Here we go. Oh, it's going the wrong way. It's tight fit, it's not working. Yeah, these things, these electric screwdrivers, I don't know. Seemed to be great when I first had it. But now I've let it battery sit in a while in the drawer for a year. Yeah, it is working. So anyway, let's get these out. Get these out of here. Yeah, because I need the stepper motor off so I can put the shaft assembly completely on it and just see how much plays on it. But trouble is you've got to hold the thing still. You've got to hold the shaft still. Anyway. Yeah, so I've been busy doing a bit while not streaming, just to get to a certain point with it. But the switching's great now. The switching's reliable and great. I'll show you that in a minute. Right. I'll show you that now, actually. Right. So I made... You can't see it. So I've made these two things. I've made this thing that holds the contact on the shaft, and this thing that's indented to go over the shaft, over the contact. So basically we'll have two different versions of these two bits for different relay contacts. So this one does a certain type of contact that fits it just right, and it's got an indent, you can't see it, two little tangs that hold it in the right position, and it's narrows down as well. It goes like that, narrows down, so it holds it still. And I haven't got a spare contact to show you yet. Or have I got a burnt out one? Let me just see if I got a burnt out one. Yeah, I've got one. Yeah, there's a burnt out one. So these are taken out of a burnt out relay, so there's a burnt out contact. The other side's okay, but I haven't put this into a model, so I just flatten the end. Just flatten the end out like that. Right. So flatten the end. So what happens is these two clip together, so you unclip the bottom bit. You put this bit goes into the piece there like that, and it sits inside it. Right, so it just absolutely sits inside it square like that. Then you put this bit over the top. If I haven't just kicked that out of the position. Right, so it just clips together like that. And it holds the contact exactly the right distance and stops it wobbling so it doesn't shake or anything. And you can get to the back of it to solder your braid, and you can even solder it before you put it together. So anyway, we're going to carry on getting this motor apart. So I should be able to pull this out of here now. Yeah, that's it. There's one of my earlier ones using aluminium, anodized aluminium. Anyway, right, I've got to get this off here now, or have I? No, I can leave that on there. Tell you what, let's take it off. Let's take it off. So this is an old model anyway, old design, so I don't need it. anymore. They've all got to be made the same eventually. So these are non-working, but I need the shaft off it. Stepper motor, sorry, stepper motor. Right, oh god, I've got terrible pain in my shoulder. I don't suffer from pains normally, but this last 5 days, went to the doctor. He says put an ice pack on your elbow. He said, that's all they got to say. Put an ice pack on your elbow. Right, so let's get rid of this. I'm glad I've taken this apart because I've got to use all these parts up. Throw all these bits away. Right, so that's nearly in bits. Right, so I've got the stepper motor, which is what I wanted off here. So I'm going to put the bottom of the shaft on. So this is the bit that I've got already. So I'm going to pretend I'm building it up. So I'm putting that onto there. Now it's already a tight fit. It's already a tight fit. Then I'm going to put in another piece. Right, this is the extension piece that sits over there like that, and that'll line itself up with the shaft. Actually, you should just turn it off. Build this up first. Build this up. Come on. It's hard to get it in. Tight fit, this one. Ah, I just broke it. That's good. Just snapped that one. That's weird. Why have I snapped? How come that snapped? I must have printed that. That must have been one with only 20% infill. Or I'm getting too strong. Even though I've got a bad arm. Right, let's put this back in here. So I've just fetched another one out. Right, that's okay. Has it gone in? Go on, that's it. Yeah, it's a tight fit. It's not sat down. There it is, there it is. Right, here we go. So that's slotted into there. Now I've got to slot this piece, the other piece over top of that. Right, so that slots over that. Now I don't know which way it is, because what I've got to do is get another piece, top piece, and an actuator. So I've got an actuator. I've got to just work out the flat of this. Goes on to there, that way around, so that tells me which way it's got to be, and then I've got to put this on top of there. Oh my god, it's a you know, tolerance fit without any tolerance. Now let's probably take this contact off a minute. Get this to start. Yeah, so you start that off first. Push that down. Difficult. It's a tight fit, obviously. Yeah, so that's down there. So you put your contact on next. So you drop your contact in, and it all lines up because it's designed for this particular contact. Then you put your top piece on that holds the contact down. Has that moved? I can't tell if that's moved. Anyway, that's there, yeah. Then you got to put on your rotator shaft. That's it. And press it all together. Right, okay. Then you've got your knob. Right, so there's your complete shaft assembly. Now that has to sit over top of... I've left the shaft behind. Left the sleeve behind. Hang on, let me get that off. I made a sleeve so if it wears out you can change it easy, but that idea probably no good. Right, so I need to put that back into there. Right, now I've got to slide the whole thing over this shaft. Right, so just the whole thing, hang on, got a rogue hair, go away. So that's obviously just going right over there. And that's as far as it goes because it's touching the underneath of that. The rest of it will be packed up with this and the old spacer like that. So that's as far down as it goes. Now well, we can just plug it in, I suppose. Plug it in down here. Now it's won't prove a lot, but at least you'll be able to see it moving. Okay, switch it on. And this won't be able to find a stop, so it'll be interesting to see what happens. So it's just gonna keep spinning around. Right, so yeah, there's no physical stop to go against. So if I do a... Right, it's just going to switch around, so there's not going to be a problem with this. What I should have done is put one of them on. You can see where it was going. We can still do that. So the problem I got is when it's in the actual body of the shell. The flat and the plastic move against each other, and I can't test it like this. I can try and grab it. It's trying to go against me. It's got a lot of torque. You can see it pushing my hand. So anyway, it doesn't really show me where the problem is. I can only seem to find that when I've got it all assembled, which then you can't see. But the problem is it's rotating in the sleeve. So I can use a coupler. I can use this coupler, fasten it onto the shaft, and then this is an 8mm that will fasten onto the other shaft, which I've got over there. So you're physically fastening this steel to the shaft, then the top of it, you're gripping the flat of the plastic, so it can't move anywhere because it's going to shred it to pieces if it tries to move, and it can't, or it'll probably stall on the motor. So what do I do? Well, that's just... Actually, I can see it moving now. Yeah, actually, it's not a bad idea to do it this way, because let me just bring that over here. If you watch the flat of the shaft, if I get the flat of the shaft like that, when the program thinks it's got to the end and it tries to swap over, it's going to backlash and then move. So there will be a little bit of movement. It's difficult to show you, but so I need to lock it in position. See, I can't lock it like that. The only way I can do is if I put some pliers on there, I'll have to stop it. It'll start going again in a minute. Yeah. So if I just pull that out. Right, so I put some pliers around it. try and hold the flat still. Alright, so I'm holding it still. And now, so the only thing rotating now is the shaft, is the plastic. And you can see I've got that much play. I've got from there to there. That's the plastic on this one. And most of that is the new sleeve actually. But that shaft goes all the way up and catches the other bit as well. So that's not really helping. So the only thing I can do, the easiest, is to shrink the plastic somewhat. Shrink it. Now I'm getting play between the sleeve. Don't know if you can see that. I'm getting play between the sleeve and the bottom bit. Yeah. So that's what made me think to get rid of that, the play between the sleeve and the rest. If I put a square or a rectangle instead of that, because it can't really move then if it's right against the sides or something. Let's try it. Let's just quickly try it. It's going to be trial and error. The only problem I've got is you've still got the metal shaft. I'll show you better on the model. Hang on. So you got, yeah, so you got the motor shaft which has got a flat on it there. Now that shaft is attached there, but also attached through there. But let's see how far it goes. So the metal shaft stops about here. So all I'm thinking is maybe it's just not ideal. You know, it's not bang on. But apparently you can't get it to stop. You need a grub screw to fasten against the flat, ideally. So yeah, that's an idea. Now the problem is, if you put the bottom back on again, the base, let's just take off the X-ray. So the base is actually, that's not the base, is it? Oh yeah, no, that is the base, yeah. And then you got your upper or your lower shell in a cage. So it sits on there and it pokes through there. Now if you go into, yeah, if you go into that, it always looks bigger. So yeah, you got that there like that. So yeah, so that's spaced out with the inner cage, sits straight on top of there next to the ball bearings. Then you've got your top cover. Right. So it's this sleeve at the minute that's hang on, let's get rid of that. It's a sleeve here that's doing most of the rotating. Believe it or not, yeah, that's that sleeve. But that is a direct copy. Hang on, let's just paint that. It's a direct copy of the other bit, this here. It's the same geometry. So what I'm going to have to do is either reduce this. Tell you what, I'll leave that as it is. Or I'll make the sleeve bigger. I can print a new sleeve, pop it in. Yeah, so that'll save me. Well, I've only actually printed 2 of these there anyway. So now, do I just try shrinking the sleeve, and then I will have to force it on. So we'll probably transfer the backlash from the outer to the inner, but it's a start. But this is what I had before I started all this. This is what I've got on this one here. This one here seemed to be okay, but this has got the wrong inners, the wrong switching. I've got another one up here that has got the wrong switching. Probably, yeah, it's probably got the wrong, not the latest switching. But this one seems to work okay. Anyway, so I could just try and work out where the problem is. It's difficult to work out because I've made this exactly the same as the bit it fits into. It's just, you know, I've used this same geometry here and printed this, so I could over enlarge it. I tell you what, that's what I'll do. At least we'll do something. Hang on, let's just do something. Right, so I'm going to purposely make this over enlarged. So the way I do that, I'll just have to grab that a minute like that. Bring that back to there and just get rid of all this a minute. I'll have to bring that back down to measure it first. So it needs to 5602. So bring that down to the base. I'll grab hold of the geometry and purposely make it bigger. I don't know how much bigger. 0.2. I'll say that much. We'll do that much, right? So I'll delete that. Bring that up 5 point. I forgot what it was now. Hang on, let's just do some undo in a minute. .602. Oh, hang on. Oh, it's all gone. It's all gone crazy, the undos have. Undo, erase. Undo, undo, undo. Right, I've lost my position now. Hang on. Right, don't know what's going on. It's all gone to stuff. Crazy. Yeah, hang on. Right, so we're there. So let's bring it down at the floor. Oh, I totally lost it now. I don't know what the real one is anymore. Hang on. Let's just do some undoing. Right, so now that inner one's wrong. So that's the original size. Yeah. So that's the original size. Redo move. Redo. Erase. Right. So bring that down to the floor. Get this. And 0.2, delete the old one, bring that up to 5.206, was it? Or 602? Don't know. 602. I've lost it again. Right, it's embarrassing. Sorry, I've been to work all day. Right, I can't remember numbers. Sorry. 602. Alright, let's try again. Shouldn't really work on stuff when you've been work all day. Right, so then we need to come in 0.25 and drop this, just gives it a bit of a taper. 0.25. So now we've got a slightly oversized thing. I'll say thing. Now, do we do the inner as well? Or is the inner okay? The inner's probably not okay. So, yeah, so you've got your sleeve there, that's going to go against the other one. Right, let's make this a bit smaller then. Yeah, let's try to make this a bit smaller. How do I do that? Not so easy to make that smaller. Right, I'll do it in stages. We'll print this one out and then we'll try it. Right, let's just print that one out. So it's slightly oversized, this one. Let's export it. What we're going to call this, we've already got a name for it. Bottom sleeve, there we go. Bottom sleeve. Right, so we're going over to Bamboo Studio. Oh, can't prepare because I haven't got anything loaded, so I'll get this one up. Right, so we want to go over to the sleeve plate. And we've got a couple of sleeves that, let's say they're the wrong size now. I'll just make these non-printable at the minute. I'll import the new one in. Sleeve, bottom sleeve. Right, so I'll just bring that up a little bit. Right, so we're going to tell it it's 100% solid. Oh, I've got an idea. Somebody says the number of walls, make the number of walls 4. Right, okay. So we're printing some more walls, but whether it'll ever get to that point, I don't know. So we're on plate 4. That's the one there. 100% fill, layer height, inner and outer. Yeah, okay, let's do that. 100% infill density. I'll try and print it. It might not like printing one, but let's go for it. Let's give it a go. It might just decide it's not going to stick and chuck it off, but we'll give it a go. We'll leave the bed leveling off. I'll just do it without the bed leveling. Let that go through the motions. Right, let's see what's going on. So yeah, we're having to make it oversized in order to get it to fit. Will it work? I don't know. The combination of that and making the walls 4 instead of 2, the wall thicknesses. So, well, the number of walls from 2 to 4. Humidity's going up on the filament slowly. This will take a while. It's going to bring the waiting for the heat bed to reach a target temperature. Anyway, so have a look what else we got going on in a minute. So anyway, I want to get all these finished out of the way because I've got another project I want to do, but I've got to work on the web interface for it as well. Oh yeah, I thought of it, another project with a stepper motor Sounds crazy, this one. It's an antenna, a long wire, but it's got a stepper motor on the end of it. I picked up some wire actually. Where are they? Wire. No idea what I did with that wire. Ah, here it is. Picked up some of this wire. It's a plastic coated steel wire. Anyway, I'm not sure if this will do the trick, but anyway, I picked that up for whatever reason. It's £2 from a charity shop. Must be Amazon return. Picked up some other bits as well. Can't remember what they were. Anyway, so what my idea was, a self-tuning long wire, a self-lengthening long wire, using a twist. How can I explain it? Two single wires twisted. You need two bits of wire and you twist it. How can I explain it? Anyway, I can't really explain it, but say if you've got some wire or string. Alright, so you got some string, and say let me just unwind a bit. So you've got two wires, right? They're electrically conductive wires in plastic if you want, and you twist. You put one end in a drill. You fasten one end down. Hang on, let's undo some more. Right. So you've got this wire. You join that onto an insulator one end, and then the other end is through an eye or something onto a stepper motor. So what you do, you turn the stepper motor, you twist it like this. There's a pre-twist on it already. You have a pre-twist on it, like this. So there's two separate conductors, but they're electrically shorted out. So hopefully it'll act as a single wire. But when you twist, when you tighten this up, if you get a drill on the end of this and spin it, the wire will shrink. Now the electrical length will stay the same though, sort of, because it'll start to load itself a coil as you twist. Hang on, let's get a drill out. Can we get a drill out? No. So basically, if I twist this enough times, hang on, let's put something through it. So if I got this connected to a stepper motor this end, can't show you on this small length. Hang on. So if I twist that like that, if I keep twisting, it's going to get shorter, isn't it? But electrical length is going to be the same because it's helically winding it. But at some point, the base loading of it, or the loading of it, will be the electrical length and the loading, the number of twists will interact, and you should be able to tune it to a certain degree. You keep this taut. Go away. So basically, if you tighten this up, you're altering. I know it's the electrical length seems to stay the same, but keep it taut. Have a small bungee one end, and so to adjust the swar, you turn it and undo it. So you're lengthening it physically, but electrically it'll stay pretty much the same. Now, would it alter enough to be able to swar it in and make it resonant exactly right? See what I mean?
London, Singapore,
anyway, that's another one. We could use a stepper motor to put the twists on it. Remotely control the twists. Out in the garden or whatever.
Direct to Oxlow, Singapore 21.
So you could basically don't bother trying to adjust the swar, just set that up do it off your phone. Well, that'll be a test. We'll have to do a bit of a test. Andy! Welcome to the stream, mate. How you doing? Yes, it will give you same capacitor. Some capacitance. Yeah, so it'll alter it because it's not a direct correlation between a coil and a length. It alters, yeah, like I said, a capacitance. You're right. Let me just say hi to Andy. Well, I can't spell today. No good at spelling today. Yeah, so anyway, that's another thing. A long wire. That what I hate is tuning antennas. I can't stand it. If you ever had a Hustler and you try to tune it, there's too many pieces to tune, and you're not sure what's going on. And most of I reckon my problem, there's not enough radials on it. You're trying to tune an aerial without any radials, and this aerial, this antenna, this Hustler, I don't short myself out in the... It's trying to... It's only half an antenna, which they don't... I don't think they tell you enough. They should stay on it. This is not an antenna without the radials. It's just it's no good without the radials. Just tell you that, and then you'll know. Trying to set it up. How can you swire it up without the counterpoises on it? That's crazy. Anyway, this thing's printing, so it's almost ready. Let's have a quick look again. Yeah, so we can put that back into the motor and see if we can get the backlash. I'm trying to get this project finished so I can get on with the web interface and get it done. And I can send these out once I've finalised this. I don't want to send them out with the wrong bit on. Then you got to get the bits changed, and you want to make sure it's spot on. It's got to be spot on, really. Anyway, so I like the idea of the this wire, not this stuff, this is not conductive, but some wire and twisting it. I'd love to see what people can't do. I mean, you either get someone in the garden on the end of a walkie-talkie and say, put some more twist on it, or you take your nano VNA out down. You can do that now. You never used to be able to do that years ago. So, I think I want to try that. So maybe I'll combine. So if I've got enough of these hanging around, I'll have one for switching the antenna and a stepper motor just to put a twist on it. Imagine tunable ground planes and whip just to get that. Alright, it's just finished that. So it's just finished. I'll give it a minute or so and I'll go and grab it. So Andy, yours is here, mate. It's here. It's here. But I've got to change the bottom shaft and the inners to this new modular bit. Got to change it to that. So I've got to create different kinds of relay strips, contacts. I'm going to create another set of these on the build plate. Hang on, let's get over to it. So if you go back to the project, on this build plate here, you can't see it, so let me just make these printable so you can see them. Right, so on the build plate, depending on which contact strip you get, that's one type, and we'll have another one for a different kind of contact strip. So it holds it still depending on which relay you manage to get hold of, Anyway, so I'll go and grab that now and come back in a second. So give me a couple of seconds, I'll go and grab it and we'll try do another live test to see if we've got rid of any backlash. So back in a second. Right, I got it. So obviously it looks exactly the same as the other one by looking at it, but it's got a slightly thicker. I'm just taking the base out of it. Right. So, which one was it now?
Wire 221, when ready, descend for over 200 level Betsy.
I suppose we could put it in this one.
200 level Betsy, flyer 221.
Yeah, we could try it in this one.
Bravo November, when ready, descend for over 200.
The ultimate test will be in the real one.
Logan 6 Lima Golf contact, London 135.
So I'm going to take that one out of there, which is, you can just feel it wobbling. Look. Take that one out and put this new one in. If it'll fit. If it'll go in. Right, that doesn't want to go in, does it? Hang on, maybe I've got to push it in. That's probably put a bit too much on it, I think. Yeah, but it's too much on that. Mind you want it to be a tight fit, so I'll tell you what, let's put it over the motor. Will it even go over the motor? Should do. No, it won't even go over the motor. Will that way, yeah, because that's it, because I've got the... You can take out the bottom waffle, very good. Good idea. What's a good idea? Oh, which is a good idea, Andy? Which one? How's it going? Which, yeah. Good idea. What, the long wire is a good idea? Maybe, or is it this one? So this is a tight fit. You want a tight fit on there. Hang on. There you go. Let me put it on the desk. Put it on the desk.
464 Mike under control.
What's that?
Knock-in.
Alright, so I've got that one. So that's on there. That's on a solid pin. Now I've got to somehow get this on. So, now this.
London, good evening, United 122, flight level 390. United 122, London control.
Might be too much, that might. Might just be too much.
United 122.
So, how do I do it?
Good evening, London, Tom Jet 801, flight level 380 to Delo, Polo 1 November, Newcastle. Tom Jet 801, London control, address Attic.
Right, so this one
Tom Jet 801.
might have gone too much. By 0.2 extra might have been, unless I can get it in.
London, good evening, Shamrock 54 Lima, flight level 340, passage.
Shamrock 54 Lima, London control, roger.
No. No, it doesn't want to go in. So,
United 122, your arrival is...
I'm sure if it went in it would be spot on, as in no backlash. How do I get that in? You need to squeeze it in. It's stuck in the motor now. Stuck on the motor. Surely that'll go in there. No, it's not going in. Right, let's print another one, slightly less size. That's a bit too much, even though I didn't really do much with it. Right, let's try it again. So that sleeve there, it's slightly oversized. Oh, the motor contact, yeah. Yeah, because I've already seen two different types of relay contact. So the one I've made works with a certain relay. Now I've got another contact here. I'll make another one to match that one. So yeah, hopefully we can have a few different ones depending on the contact. Right, so I need to then make this a bit smaller.
Control service and contact Dublin 135.
So I just need to bring that, fetch that back up to there, delete. I'm just wondering whether I did it twice. You know when I lost my position on it, did I actually do it twice?
When ready, descend over 270.
I might have done it twice, maybe that's why it's too big. So let's just reduce it. Reduce it by a little bit. Well, I did it by 0.2, so let's do 0.1. So smaller by 0.1. And for some reason I can now remember it was 5.602. Couldn't remember earlier. Like I say, we've been out today. Where have we been? Lutterworth working today. Big industrial site, Magna Park. Magna Park we've been working today. A brand new building. Right, okay, so we've got that there, so we'll just output that. This is going to print this and it's going to be very slightly smaller. The good news is it doesn't take long to print it. Right, so let's get over to here. We'll get rid of that one, that didn't work, that was too big. Import.
221, contact Dublin 135.655.
There it is.
135.655, flyer 221.
I'll put it back where it was. It seemed to print alright there. Okay, so I've just got to make it 100% infill. And number of walls 4. There you go. Alright, splice that up. Trial and error. Print. 10 minutes. That's a long time to print a little piece of that, only 10 minutes. Oh well. Yeah, so contacts. See, they're silver plated, those contacts. You've got phosphor bronze strip with a silver plated rivet for the conducting.
JetBlue 1107, flight level 350. JetBlue 1107 under control. Director Jetsi, your arrival is Zurich 1 Hotel.
Yeah, so if I can get rid of the backlash on the outside.
Zurich 1 Hotel for JetBlue 1107.
If I can get rid of the backlash on the outside of. That's going to be stay the same. So if I can get rid of this backlash between the outer plastic and the base, then if I've got backlash in the middle, and I can shrink the middle a bit. Well, you're constrained from the side of the shaft. I've got various couplers, so that coupler is 5mm one end, 8mm the other. And you can bolt that onto there, screw it up onto the flat. And this is what I've done with this one. What I've done with this one is I made an extended base, and I've put a coupler on it, and I've screwed that to the 5mm shaft, and the 8mm plastic shaft I made, it's screwed up the top, and there's no backlash on it, but it's made this bigger, and because it's made that bigger, I would have to create a bigger one of these to accommodate it. Obviously it's not going to fit in. But I did actually redesign it already, but I don't want to print one out. I think it's big enough as it is. But if we have to do it, if we can't get rid of it that way and keep a small one, if we can't keep the small one because of the backlash, we'll have to do it that way. Yeah. So you can get a flange mount as well. You can get a flange mount one that fits onto a shaft, a bit like a pulley wheel, a bit like one of these pulley wheels, but it's got a flange, and you put your fixings through a flange, so you'd have to develop a wider flange where you can screw your fixes into. So anyway, I'd rather do it this way because I keep it low profile. That one works well. This one's got backlash. When I tried some of them, they had no backlash. They were working okay. Whether the print just happened to do a better print, or whether some of the earlier models were something's changed on the newer one. Anyway, that's going to try and print in a minute. So let that carry on. What's it doing? Cleaning the nozzle. Yeah, it's dropped a bit on the table. Look, dear me. Anyway, the good news is this all paid for, that is now. So anyway, that's the good news. Right. So what else are we doing? What's this say? It's cutting, getting rid of the backlash. Yes, we're doing that. That's what we're trying to do. Get rid of the backlash. So trial and error. So I could do both designs if you want to be sure. If you want to be sure you never get a problem with backlash or wear, use the coupler. These couplers not that dear, they're about three quid each, 3 or 4 quid. But they're 25mm long, so they take up that extra 25mm of space.
132.840, Singapore 21, good.
And I could go back to a very original idea of having the motor set off with a belt driven and a pulley.
Long and good evening, Boston 1 Single Quebec, passing.
But so you'd have to have a pulley wheel that sits over.
Ocean 1 Tango Quebec.
That wouldn't be no good, but I've got another pulley that fits on an 8mm shaft.
Roger, stand by higher.
Somewhere. There it is. Yeah, I've got one that'll fit on an 8mm shaft. So that's the same as that one there, yeah it is. So that'll fit on an 8mm shaft. So you could 3D print 8mm round shaft and screw that on and have your stepper motor connected slightly off with a bit of... And that way you could even have the belt, you could clamp on a physical stop onto the belt, so instead of it fitting a physical stop inside. But anyway, that's gone past. But there might be a use for that for a different task, because I wanted to rotate. Oh, that's heavy. So I wanted to rotate this thing from remote. I want to be able to rotate this from a belt drive off a stepper motor, so to keep it away, all the electronics away from the driven plate and all that one. So this thing would actually spin around. It would spin, you know what I mean? Spin around, alter the angle, so you could alter it. First you could alter it that way, and you could tilt it and alter it that way as well. Anyway, that's another story. Anyway, that should be printed by now, shouldn't it? Oh, started printing. Oh, what's it printing? I must have left something else on. I'm printing them as well, so it's printing 3 things. Oh well, that's why it took 10 minutes. Yeah, never mind. So that is why it's taking a little bit longer, because I forgot to make them non-printable. But I need some of them anyway, I think. Do I need them? Yeah. What am I printing? I can't remember. Oh, yeah. Oh, we need a set for Andy's one to upgrade his contact. Yeah, so this one, oh, you can't see it on that. Let's go on to this here. This is it. This 2-part thing. So you've got the bottom bit that holds the contact. It just sits in there. Hang on. Can I turn it on? Oh, it's already got the contact strip there. Yeah. So the contact strip on this bit, it just sits on top. Hang on, we need to get that over here, don't we? Hang on. Yeah, so if I go into that now, so it's awkward. Hang on, how awkward is this? Right, undo that. Undo, close, undo, close, undo, close, undo, open, undo, paste, undo, open, undo, cut. Right. So the problem is that is in with this model, isn't it? Yeah, I need to bring that out of there. Paste it into there. Right. Yeah, so if I... Hang on, can I get rid of that bottom bit? So I need to get rid of the bottom bit just so you can see. Or make it X-ray. It's too much going on. So, yeah, you can't see it. So that contact strip, it's tapering out, so I've made it taper and it fit this just right. And then there's a bottom block that's pushing it up inside this other bit, so it can't rock sideways. And you can undo it to solder to it and drop it in, fasten it in. Anyway, right. So
Rhino 30 Lima under control, direct Bamba.
Yeah, it's got tapered, so the other one I did, it was designed for a flat copper strip out of a different relay. And I started using this and there was too much play. And these little tangs here sit around the actual copper strip. The copper strip's comes with these little cutouts. So then you got your phosphor bronze, then you got your tin silver plated. I'm having trouble working this software today.
Right, 30 Lima, climb file 380. Climb file 380,
Yes, it's got these silver plated ends. And this is just a solder, where you solder it, just a representation of a solder blob. Yeah, so that one would fit straight in. I've had to model that exactly to the copper strip to be able to make the bit that goes round it. To make this bit exactly the right size. And then this other bit pushes that down and keeps the copper strip down in between the two. He pushes it in here. That's it. And the copper strip stops there and the plastic goes into there. So it holds it down. So when you're going left and right, the walls here hold it in place. Anyway, so you'd have to change that bit and that bit.
United 122, descend for over 140 level Zurich.
These two bits is what sandwiches the contact strip, but the rest of the shaft is the same.
JetBlue 1107 when ready, descend for over 270.
This bit's interchangeable.
JetBlue 1107.
Now, if you wanted to do the bit,
25 Bravo, direct to Meadog.
Sorry, repeat myself here. If you wanted to do that one. Right, so you need that one there. That is the one that fits the long shaft. So your stepper motor would slide up in there, and this would be your 8mm that you'd attach your coupler onto.
7190, when you're ready, descend to flight level 200.
You can't see it on that one. So get rid of the motor and the spacer, and then and also the base. Oh, there's no base. Right, okay. Then bring back the long modular. Where is it? The motor long and the coupler. So I haven't to put the grub screws in, but so that would tighten up onto the 8mm. It's got more to tighten up on. So on the flat 8mm, you put your screw, you tighten your screw, and this would tighten up onto the 5mm shaft. Right. Anyway, what's going on with this thing? Is it finished yet? Oh, 3 minutes left. Yeah, 3 minutes left. Okay, let that carry on for a bit. Right, is it? What else? I picked up some stuff from a charity shop the other day. Picked up a pack of these. Something to do with bed leveling, proximity sensor, something. It says Z Pro car bed leveling.
34 Yankee on the control, roger.
Don't know how to Google it. So look, they don't seem to press or anything, so they must be proximity. Oh, I picked up this as well. This was £1, a 100mm linear bearing. It's a linear bearing slide, so you can move something like that. I don't know. I've got another one, a longer one, so slowly getting bits, picking up bits. What else have we got? about it. Oh yeah, that wire. I don't know how much this wire there is. It's steel wire, like washing line, but it's stainless steel. It's got plastic coating on it. So it looks quite long, so maybe you can make a guide wire or a long wire, maybe a long wire out of it. That was £2.
X 9 Papa Charlie,
What else do I buy?
Check
Can't
9
remember
Papa
what
Charlie
else I
on
bought.
control. Roger, direct to Farjo, your arrival at Kojak 2 Bravo. Okay, we're direct to Farjo and your arrival
Also
at Kojak 2
bought
Bravo.
these 3 rods
United 122,
for
contact
£2.
134.125.
They're aluminium rods, billet rods, 15mm diameter. So I've thought about, wouldn't it be nice if I could make one of them, a low profile one, but then you need a little micro miniatures lathe. Yeah, so you'd have to put those in and you'd have to do some tiny little lathe work anyway. So they were £2. What's it say? 3 pieces, 15mm diameter round. £2, I don't know.
JetBlue 1107 when ready, descend to level 140 level Zurich. Alright, we're ready to descend to level 140 level Zurich, JetBlue 1107.
Still going, that thing is, blooming hell. What else have I got? Did I do anything else to the model? Oh, it's just finished. Just finished, that has. Right, so we can try that again in a minute. I'll go and grab it in a minute. So did I do anything else to this model? Yeah. So the main thing I did was model this longer one. Now this is a solution. It's the solution to the Backlash, but obviously your bigger unit. If all else fails, I'll just go with that, if it works. If I can't get rid of the Backlash. Right, I'll go and grab those things. Back in a second. Right, we're back. So I've got this and that. That one I'll sort out later. So let's get on to this. Let's just peel. This is the brim. Just peel the brim off it. And poke through the inner brim. Right, so that's actually come out pretty good, I think. Yeah. So, will this one push in? That's the thing. Will this push into there? Let's try it. It's 0.1mm less than the last one. Now, the other thing is, have I damaged this one? Trying to push the other one in. Is it going? Possibly. Tell you what, let's just grab this one off here. Take this one off that was too large. If I can get it off.
When ready, descend to level 280 level Attic.
Yeah, it's a tight fit on there, alright.
Flight level 280 level Attic.
Right.
801.
I have to get rid of that. I'll leave it there for now. Right, let's put the new one. Start the new one on here.
5 Kilo November, climbing 210 and heading at 259.
So that goes on there, okay.
5 Kilo November, London Control.
Now, can it go in here?
36, please, Rhino 5 Kilo November. Rhino 5 Kilo November, copy, standby higher.
360 to Oxford.
Oh, it's going.
Tango, London, so 65 Tango, London Control.
It is going.
Oxor, and then
I'm just going to put that underneath so it doesn't go all the way down now.
Oxford, Bouncy, 79 of British.
I can push that onto there.
Contact London 132.860. 132.860.
It's going.
Red North 57288.
So I think what I'll do is I'll just try. It's not all the way in because I want to put it onto the real one. What I'm experiencing.
Hello, Ryanair 737 Alpha 32 Northeast.
Backlash, is that
Ryanair
backlash?
737 Alpha London Control Address, E-Pace,
So I can put it in. Tell you what, we're going to have to try it on the real one. So if I push it on here, I'll never get it back off again. Right, so I'm just going to leave that there a minute. I've got to dismantle. Yeah, I've got to dismantle this one, I think. Hang on. Oh no, this is easy. So this one pulls off here, right? And there's the sleeve. So there's the same original one. So this will be easy. And I've just got to pull that out of there. There's the one that's too small again. Now I've got to get the one off this. Push it into... Well, either into there, or I'd rather push it into the bottom of here, which has already got the right receptacle part. So I can just push that in there.
Right, 9 Foxtrot Whiskey contact London.
It's not easy. Tell you what, I'll use this motor to hold it square while I try and get it in. Right, so I'll use that to hold it square. And I should be able to start it off. Oh yeah, it's going in, look. Right, so...
Good evening, Flyer 30 to Foxtrot, Passport 370 Pablo.
So I'll just wobble that off there. I think I've brought it out, hang on. Gonna get it back in again.
5 Kilo November, to Me Dog, then Badsy.
Yeah, gonna get it back in.
Ryanair 30 Lima,
Trick is to hold it square. That's it. Oh yeah, there it is.
When ready,
so I can just use something like this, or just put it on a flat surface. Tell you what, let's put it on a flat surface here. And just push it in. You can hear it going in. Put a bit of pressure. Has it gone in? Nearly. Bit more.
Janix 9 Papa Charlie, descend to flight level 200.
Right, okay, so we're in. Right, so we're pretty much in. So let's stick this on then. See if we've got rid of any backlash. So I want the common just to that point there. Push that all the way in, like that.
1 Tango Quebec, contact London 134.460.
Just make sure it still rotates, it does.
134.460,
Right, okay, let's plug it into the stepper motor. Plug it into the stepper motor. And we'll see if we've got rid of the backlash.
Roger, if you're at Carno, Al-Hub, and then Webby, and standby for every son. Carno, Al-Hub, Webby, EC3000.
Right, is it doing anything? Oh, I've got the power supply switched off. So let's, right. Didn't do any homing. Let me just reboot. Right, it seems to be, it's gone okay. The other, that always goes okay that way. Let's see if we can go around the other way. And back. See if there's any backlash. Right, let's put it on a sweep now. Right, here you go. Run the sweep program. Alright, let's bring it's on. It's running the sweep program now. So you can tell if there's backlash because it doesn't point to the right. Not when it reverses, it points under the 6. So that's seems to be functioning okay now. With that, just a bit of extra sleeve.
Easy 325.
I don't know what we're doing here. Oh, how you doing?
Heading of 175.
I just welcome everyone to the live stream. Sorry if I missed you. Here we go.
London 134.125. 134.125, JetBlue 1107.
What we're doing here, we're messing around making a 7-band or 7-position antenna switcher that you can use manual or you can stick it on in your garden in a weatherproof enclosure and remote control it from anywhere in the world or from in your shack, inside to out wirelessly on your phone or on a app. So we've attached a stepper motor to a manual one which we've made from scratch. Bought the SO239s, reclaimed a contact out of a relay to use as the switching, and we've got this on test now. We're going to try and get rid of backlash. We got rid of backlash if we use a proper coupler, 5mm to 8mm shaft coupler. That one works perfectly without any backlash, but we've gone from that size to that size, so we've gone bigger, and we don't want to go bigger because means we won't get it in a weatherproof box if we're bigger. See, it won't fit. I've got it around the wrong way. So we've oversized an inner sleeve on the end of this shaft, forced it in, and see if we generate backlash. Where what we were getting is when it was going to 7 and going back, it would only get to sit just below 6 and then carry on going. Once the backlash was taken up, or the slackness, it would then go to below 5 until it got all the way to the end, then it would line up again. So basically we can put in on that, can put a meter on it. What have I done with that meter? So we can do some belling out. Yeah, so we're gonna make this switchable thing off your phone. Ultimately, I've got one in the shack here on a bracket. I've got a bracket mount here, so it sits on a Yaesu microphone bracket, which is the same as this thing here. You can 3D print, and it just slots in there. So I've got one in the shack here. With that one you can switch your feed cable from outside to different radios or whatever you want to do with it manually, or both, one outside in a weatherproof box that you can switch from in here off your phone. Right, let me just put the meter on here again. I'll just bell this out if I can reach. Can I reach? Almost, not quite. How many losses on connectors? Yeah, that's not decided yet. This is entirely experimental. Now it's using a relay contact, a silver-plated relay contact on a braid from the feed. So they normally do it with switching through various relays, 2, 3 or 4 relays. But I didn't like the idea of the relay coils. Are susceptible to the RF energy, so you have to buy relays that are able to cope with RF. supposedly. So that sounds expensive. So anyway, the other way is the old-fashioned way of this cheap-ass switcher. Just got a button, just switches it directly. So that's cheap-ass thing. So anyway, yes, they got the frame ground. All the covers have got the frame ground on them. So they got a silver backing. So we've done what we can do there, and it's as small as it can be, grouped together as small as it can be, sandwiched in the frame grounds. And anyway, so that off the back looks like it's got rid of the backlash, but obviously the more I grab it and try to withstand it, will it develop backlash? I don't know. It seems to be okay. So anyway, what I want to do is some test. I've done tests on it before, but I have put a lot of force on it now, and I've altered the shaft position. So I just need to see. So we can measure frame ground, common. So you got your frame ground. So if I put this probe into common, and I go into like 5, now 6, now 7. It's quite a good firm fit. And for it's gone into 10-second pause. Right. So I'll just leave that there for a second. Yeah, that's 4, okay. Now 3. Two. And 1. I'll get it in there. Yeah, so you've got continuity all round, and it's using the same technology as a relay, industrial relay. Was thinking about switching omnidirectional. Omnidirectional to directional with different gain. Omnidirectional, right? Yeah. Well, it is an experimental thing, so probably there's things I've not thought of. Sometimes you develop stuff and things that it can do or be useful for turn up later on. It's basically a solution looking for a problem. It's what normally I build stuff. A solution to that needs to find a problem. Anyway, now what I'm going to use it for myself, I'm going to run. Let me just quieten that off. I'm going to run some long wires and different wires at different angles. Some tuned, some untuned. I'm basically trying to, like a net, cast a net. I'm trying to catch signals and get rid of noise and different things. Just imagine if you've got some wires long, untuned, pointing up, left, horizontal, diagonal, whatever. You know, going as long as you can, as short as you can. Imagine all that, and you're able to switch from your phone. You could do a dwell, set the dwell and do a sweep, or you can just switch manually and decide which one is the cleaner signal as a receive antenna. So basically use it as a receive antenna. If you don't trust it enough to transmit on, just use it as a receive antenna. If you've got your own dedicated output for your transmit, stick it on your receive, and you could try anything. You know, if you're getting noise, I get a lot of noise here. In fact, the funny thing on HF today, I was on, what was I on? I think it was 20 meters. Lots of noise and nothing above the noise hardly. And then all of a sudden I was just sitting here doing nothing, and the noise floor just dropped underneath. It just went, and I thought, well, I've not changed anything and nobody's changed anything, so I don't quite get it, unless, don't know, it's a weird one. It's for receiver. We say it's for receiver. So HF RX antenna switcher. Now say that because imagine if someone made one themselves and they blew their radio up. If they blow their radio up, I don't want to know. You know what I mean? I mean, I've done what I can do mechanically in design, but if I say it's a receive antenna switcher, then if someone said I've blown my rig up, and I say, well, is you transmitting on it? They go, yeah. Well, I said, you're not supposed to transmit on it, but I'm going to transmit on mine. I've tried it already. In fact, I'm going to put that one up here in a bit. There's nothing to transmit. There's no HF about. I wouldn't use it on VHF or UHF, although it might be fine. I wouldn't use it. If you keep it on HF, you're not dealing with those high frequencies. So anyway, yeah, that's basically it. We've developed it over a series of 41 episodes, many hours, probably about 120 hours worth of work, altering and many iterations. So there's one of my earlier ones, made out of aluminium, anodized aluminium, and screwed into place with this, what seems not very good here now. It's obviously grown better over the, over the thing. Oh, we got another one. Another one we did with copper clad boards. Still, there might be an option that. 5.8 gigahertz. No, I wouldn't be trusting that. Not for something like that. You need to have the equipment to do tests on it. So anyway, this one was made with double-sided copper-clad board. It was one of the earlier ones. SMA. Yeah, I did what I thought of, because it's made of. Hang on, can I show you what it's made of? It's basically made of these. This is what's on the inside of it. There's one of a loaded unit. So it's basically, these are arranged exactly around in a circle. Then you've got your frame ground. They act as a frame ground, and when you put that on the top, they touch the top and the bottom. They actually touch, and when they're clamped together, it's completely frame ground. How good it is, I've got a signal generator and I've got an oscilloscope. That's all I've got, and it's a 200 megahertz oscilloscope, 2-channel. That's in my electronics lab, which I don't bring out that often. But for RF, I've got nothing for testing RF, so it'd have to be left to the community to do their tests on it. Anyway, I like the idea. Yeah. Well, yes, 3D print as much as you can. Now I was gonna, instead of having these lids, I was gonna make a PCB, and I might still do yet. But I came across with this foil idea, and I've seen it in a commercial product. So they do use a foil, and the electricity, the electrons, they don't run inside the core; they run along the outside. So if you've got a wire, it runs down the outside. So this is maybe a similar thing. The only way I can test it is if I put like some 20 watt bulbs on it and put some power in it, 12 volts, and switch it that way. But the contact is from an industrial contact that switches signals, so it's not RF, but it's a damn sight bigger contact than you get in some smaller relays. But yeah, I don't know. I would limit it to 250 watts if you do put transmit down rate power. I wouldn't go much above that. But yeah, it acts as a shielding. Yeah. There's a lot of designs that's changed, iteration design from the initial. Yeah, they've got these cages that hold them in place. So while you build it, then the brass inset screws, inserts, and then you screw your lid onto it, and the lid is clamped across all these, and there's just enough sticking out. You can't see it hardly, but there's just enough metal sticking out that you can't see a gap, but they all touch and they're self-leveling. So as you screw the plates down, the top and bottom cover, they're loose. They have to be loose, because if you put fixings in and tighten them up, you'd never be able to get one level against the other without undoing it all. So they're self-leveling, and it clamps together. And they 3D printed this cage just a fraction smaller, so you've got to use all the same type from the same manufacturer. You can't just be buying odd ones. You can use, I think they're 25mm square, but you can use on about SMA. I'm pretty sure I might be able to get these in N type, and maybe get them in SMA. I don't know. Be nice if you could get the same frame, the same size fitting, and you could put whatever you want on it. Basically, you can just put whatever you want in it. Anyway, so I've made enough bits to make 10. There's these are made up out of 4 bits. There's 4 separate bits, and they got the brass inserts in, so they just lock together just to stop it falling apart until you build it. And once the lids are on, it's all held together. And you've got these inserts that go inside, and they hold the SO239 in place. Hang on. So you get your SO239, you push it in there like that. Alright, and when you've got them all in, you push the shell, you push that in there, and it's spaced so it just fits in with them all in. And you put one on the bottom, and it's also a guide for the shaft as well, and it's a ball bearing. In there is your ball, you stop. There's a physical stop, and your ball bearing recesses, so it clicks, it snaps into place. So the ball bearing is like you're switching, so it snaps into place with the ball bearing, and you get the sound like this. Nice snappy sound. So the ball bearing, normally it'll work with a spring, but you don't have a spring because there's a natural springiness in the plastic as it rides up and down. So that just, anyway, that is the idea. Then there's the web interface, which connects to the controller, not this controller, a different controller, and then you can basically run it off your phone. Yeah, run it off your phone. So anyway, let's have another look at this, see what's going on with it, see if it's still got no backlash. if your hearing's good, you can just hear the click. You can hear 2 clicks, the ball bearing, and then you can hear another click where the contact just happens to touch. There's sort of 2 clicks in there. Looking at it, I think the backlash is not there. Yeah, it's spot on, isn't it? Yeah. Okay, now I don't know how long it'll stay like that. If you used to grab it, well, let's grab it. Let's just grab it now. Right, let's stall it. So I'm going to stall it on purpose. So I'm giving it some abuse by stalling it. Yeah. Now it will be out of position, but it should right itself again. As soon as it hits a stop, one end or the other, it'll right itself. Let's just have a look. So even though I give it a bit of abuse, which should have created some backlash into it, all you got to do is set your torque on your stepper motor driver so it stalls before it, you know, so there's not enough pressure for it to do damage before it stalls, if you know what I mean. Anyway, so that idea of an oversized one's okay, I think. Yeah, it seemed to work. So anyway, if I do, if I go back to the model, so what I'm trying to avoid is using this coupler and this long motor with the, so let's get rid of that then for a minute. Stepper motor coupler, let's get rid of the long motor, bring back the small motor and the spacer. Alright, so we've got this bit here. This is the motor add-on. So if I turn the motor add-on off, hang on, where is it? Stepper motor add-on. Get rid of all that. We've got that belongs to the long motor. So let's turn that off. Which one is it? That one. Okay. Right, so that's what we've got there. So you've got your carrier that holds your contact. So you've got, this is your relay contact. It's basically you're cannibalizing or you're reclaiming an old burnt out relay. Use the relay contacts that aren't burnt out, if there are any, or buy a brand new one, and if you get a 3 position one, you get 3 contacts out of it. You only need 1 contact. And the good news is, if you ever wear that out, you can turn it upside down and use the other side as well. If you look at, this is how it contacts the shield. Hang on. Right, so just put them back on there. Right, let's hide some of them. Right, so just keep the feed connector. Now, get rid of the feed connector. Can't see the rest of them. There you are. The outputs, turn the outputs off. Right, so we've got you've got position 1 and position 2. Alright, put the feed one back on then. If I can find it. Where's it gone? Yeah. Right, so your feed comes in here, and this is position 7. So your feed comes through on a flat braid or a ground strap. It's soldered there, and it comes round here, and it goes soldered into there. And then this, as it rotates, because it's round, it hits the side, and as it positions itself in line, it rises up on it, which automatically gives you a nice bit of pressure to make a good contact. Yeah, that's how it is. Now these are in place; they're quite tight. So when you when you assemble them, you've got to make sure your the hollow bit where you solder is down. If they're not, you might have to get some pliers and rotate it. It's very hard to rotate, so I don't know what happened on long term, whether it would start rotating. But it is going one way, then the other, as you switch back and forth. So theoretically, it should, and I don't think there's enough pressure for it to turn it. Anyway, you could use some kind of switch cleaner on it or something. So there's that. And you've got your ball bearings, 2 at the bottom, 1 at the top, and both of the carriers have got ball bearing inserts, so the ball bearing will ride up and then drop in place, and that's what gives you your clickiness, snappiness, whatever you want to call it. And then your top one is your stop. Your top one has got this extra bit of plastic just there instead of a hole, and that's your number 1 and number 7 stop, and it works off the shaft. So it works off the top of the shaft. Hang on. Yeah. So either side of this ball bearing, that flat face there and that flat face there is your stop. So that's you can't switch onto your feed, which is your green one. So that cam, those stops prevent you from ever being able to go back on itself, which is okay because you've got an earth strap tied to it. There's only so many times you can rotate, so you need to prevent it from rotating too far one way, too far the other. Anyway, I did have an idea. Let's put them all on. I did have an idea of at some point going a bit wild, and now this actually wouldn't work, would it? It wouldn't work because this distance is set in stone. Hang on. I thought about putting these wider out so you can get even more ways to switch. Oh yeah, your centre pin on your SMA. Yeah, I've got some SMA stuff here. Not switching though, it's just for the nano VNA stuff. Yeah, so I don't know what it would look like. So yeah, you probably wouldn't be able to use that idea on SMA. But what you could do is get an adapter. Probably can get an SMA to PSO239 adapter. But if it's gigahertz like you were saying, I'd say it's totally the wrong thing for it. It's HF, really. To be safe, HF is a bit more forgiving. But yeah, unless it's for is it just receive only, or is it you're trying to transmit 5.8 gig? I'm not familiar with that one. Yeah, sorry, I'm not familiar with that frequency. Is that a new band, or is that something else you're looking at? I should know, but I don't. Anyway, so that's basically what this is. Adapter, more losses. Yeah, more loss with adapter. Yeah, that's what you mean. Yeah, you do get losses. Yeah, so sometimes I like to put the coax feed straight in the back of the radio without SWR meters and power meters and stuff. But at the end of the day, your modern day shack is got to get. You're gonna have connectors. You're going through walls or out into a junction box outside. You're gonna have losses. How much loss? You get a lot. You can get just the receiver. Okay. Yeah. Just receiving. Yeah. No. No, I've got no plans to do an SMA switcher. I didn't plan on this taking this long. It's what we're up to now. 41 episodes of about between an hour and sometimes 4 hours each. I asked ChatGPT to tally it up. Going back a few episodes, it had already got up to 105 hours. So yeah. Yeah, it's designed to be adjustable, but whether you could do anything with it. I mean, if you had to use SMA, maybe you'd have to solder something like this round bit over the end. I know you can probably get N types in the same size. I've not tried. In fact, let's have a look at that. Let's just see if we can find an N type. It'll be interesting to change it to N type. Let's just do. Let's ask ChatGPT to find it for us. Right, let's just go on here. Right. N type panel mount. Panel mount. Female. See what it finds. Oh, yeah, tired. Oh, yeah. Yeah, so all we've got to do is see if they're the same size. That's definitely an N type, isn't it? Rapid electronics, are they still a thing? I didn't know rapid electronics were still going. God. Right, so we've got this here. Is it going to give a size? No. Oh, that's different end on it anyway. Right, so you've got a different end on that. Look, straight away. That's even got a gasket, that one. So that's out of the question, isn't it? What about this one? That's got a round one. Look. Yeah, that's what you want. A half round type of thing. Yeah, so if that's 25mm square, right, let's have a look. See if there's a data sheet. Is it 25mm square? What's all this rubbish? Go away. Right, information, body size, right, technical data sheet. Go away. Right, so 25.4, yeah, looks like the same. So we could put N type on as well if you wanted. I'll tell you what, while we're on, let's have a look at an SMA one. SMA female panel mount. This is still going in the background, this thing. Can you hear it? Right, so is that what you mean, Cobra 4829? And up to 11 gig, probably now. Your gigahertz, you're looking at gigahertz, yeah. God. So they don't like panel mount. Oh, you've got to make your own panel out of it. Oh, that's a through one, isn't it? RS, they do one. Oh, one little picture, that's it. That's all you can manage, is it? Shit, no wonder they don't sell anything. Just one little... How can you tell from that? Right, that's a shame. That N type, yeah. That was an N type, yeah. More sources. Dear me. Let's have a look at this one. Oh, it's heavy. Is it still going? Has it moved? No, it's fine. That's okay then. I feel a bit happier about that then. So if I put a couple of spare sleeves in with the kit, if they do damage it, they can swap it out. Yeah. Right, what have we got now? Oh yeah, there's something. Oh, that's got a connection both ends though. Ah, there we go. Yeah, very expensive. Right, so we've got... Is this what you mean? You've got female and male. Oh, 0.24 of it. 6.2 mil. What's the body on it though? They're normally pretty good at showing the size of stuff. That's the kind of thing you'd have to buy. Yeah. That definitely is bigger than 25, smaller than 25 mil. Does it tell you here? Length, width, height. No, it doesn't tell you a lot. Anyway, right, let's have a look. See what we got. 2 hours, night 17. Alright, I think that's enough for one night, isn't it? Now, so did we get rid of the backlash? We got rid of it. Whether it's a permanent we got rid of it, I don't know. Yeah, don't know. Anyway, let's shut it off. Let's stop it. Shut it off. Turn the power off. Right. Okay. So I don't know what's going on now. Let's have a look at the thumbnail. Getting rid of the backlash. Last problem. So that was the last problem to solve.
Ryder 61 Papa November, when ready.
We got rid of the problem with the contact.
10 miles before Bamba.
Now we got rid of the backlash, supposedly. So I think we're ready to finish assembling. So if I print a load of, get rid of these, I'm going to throw these in the bin now, these old wrong size things, they don't get mixed up. Put them in the bin. When I say bin, I mean plastic bin. So, I can carry on printing the rest out and finally finish off these things. So, yeah, at least it works. Now, if it turns out there's a problem, then they'll have to go back to this one. But that one's the better one. And you can as well, you can actually get a low profile version of this stepper motor, NEMA 17. Half the size. So that would make it even. But anyway. Well, I think we're about done on this one. I think I've covered pretty much everything I wanted to cover. So I think we'll go back to there, and anyway, yeah, thanks for joining in. It's all anything's welcome, good or bad. Any kind of criticism is good. All I can do my best on it, and I've gone to 41 episodes, so all that's left for me to do is to just assemble these 10 units. Now I was thinking of putting them on eBay and trying to sell them at cost. I don't know what to do with them, just to get when I say cost, just to get the part that the SO239s were the most expensive bit. really, and I don't know. No idea. I don't know whether to make more of them or just do this 10 and get rid, and that's the end of it. I'll probably want a few. We'll get one over to Andy. Andy's having one. Anyway, thanks for participating. I'm gonna do one now. So, whether it'll be a 42, I suppose there'll have to be a 42. There'll have to be an episode 42, but what that episode is, I don't know. Oh, yeah, we're going to carry on because we'll be doing the web interface. And if you don't know what the web interface is, I can quickly show you. Let's quickly show you the web interface before we finally go. Right, so we've got the gadget here. We've got, this is the ESP32 controller, my general purpose one that you can connect a stepper motor drive into and run its web interface to switch over. Let's just bring it up on the screen. So let's do it off the phone. Right, why not? So I'm going to put that on my shoulder so you can see it. Right, it's going to fall off because it's definitely going to fall off. It's falling off already. Right, what can I do with it? What should I do with that? Put it there. That's it. Stay. Right, so we'll get it on the phone. We'll do it one time before we go. Because, let's just put the IP address in it. There it is. Right, okay. Yeah, so what you've got is you've got your web interface on your phone. This is my project that's an access control system, but the technology behind the web interface is what we're going to use, the same controller, the same web interface. So you can log in, you can't see it on here, but you log in and then you can use the buttons to switch the thing. If you watch it over there, you'll see it turn green. See it turn green, so switching a relay. Okay, it comes with an event log and all the rest of it, and the network side of it for setting up over-the-air firmware updates as well. Does all that for you. So we're going to replace these buttons with a pictorial representation of this on the screen. Sort of like, can't get it, it's bigger than the screen, so I'll shrink it down. With a couple of buttons underneath, sweep and dwell, so you can adjust it. If you want just to keep switching back and forward, you can. You can switch directly to a channel and whatever, from remote, anywhere in the world. Anyway, that's the whole idea of it. Anywhere in the world, or in your shack from here to in your garden, if you want. So that's not the size of it. That's got a power supply built in, but it's normally something. I can't show you. I haven't got one. But here's a board. Here's a board. Here's the size of the board. There's a PCB. It's 100mm by 50mm, and that will have all the other bits on it to control. That'll have all the bits on it to control the stepper motor driver. Anyway, all right, I waffled on long enough, so I'll say 73 all. Thanks for joining in. Alright, have a good one. Thanks, and I'll catch you on number 42. Bye for now. I'm out of here. Bye bye.
Just find the right place in the program, make the appropriate change, and we'll run the whole thing again.
Speech is still very complicated. Music is simpler.
Is that a question?
Yes.
The question is futile.
My interpretation of the data leaves little room for error. The art of leadership is delegation.
That information is not available. This constitutes all available data.
You know what they say. No good deed goes unpunished.